on DPE 5A Section 1. And our group members is
Rishikesh Ravi 05 DPE 14F2057,
Shashi Maruti 05 DPE 14F2005,
Kumaresan Parmasamy 05 DPE 14F2068,
Loganathan Velmurugan 05 DPE 14F2031,
Subhas Selvaraju 05 DPE 14F2071, Jun Theodora Anna Daud 05 DPE 14F2003. Our title is about acetic acid.
Do you know what is acetic acid? Acetic acid is a material used for production of vinyl acetate, acetic anhydride, polymer grade terephthalic acid (PTA). Methanol carbonylation process is also called as synthesis from methanol and carbon monoxide. Other methods are oxidation of acetaldehyde, direct oxidation of ethylene. The acetica process produces acetic acid based on the presence of proprietary heterogeneous rhodium catalyst in the active rhodium complex. Proprietary heterogeneous is chemically immobilized on a polyvinylpyrene resin. To minimize attrition of solid catalyst material, a bubble column reactor is employed.
Advantages of immobilized catalyst system over the conventional liquid rhodium catalyst. Handling of catalyst is easy because it need not be recovered by separating the rhodium from the reaction liquid. A high level of reactor productivity can be obtained because the concentration of rhodium can be increased without limitation imposed by solubility. The formation of byproducts can be suppressed because operation is conducted under a low water concentration. The corrosive environment is moderated because the concentration of hydrogen iodide is decreased.
Principal reaction. Usually, acetic acid yields based on the methanol and CO consumption are greater than 99 to 92% respectively, similar to shown below. The net reaction in the carbonylation of methanol is as shown below. Acetica requires no additional water to stabilize the active rhodium complex. The reaction solution contains less than 8% water according to the following equilibrium reaction. Hydrogen iodide is formed in the reaction solution by hydrolysis of methyl iodide.
Catalyst preparation reaction. Promoter CH3I, the acetic process use methylated iodide as the promoter for the carbonylation reaction. The method of production CH3I is a methyl iodide generation as shown below. Process features. High productivity, few mechanical problems, moderate corrosive system, high product purity and low by-product formation, competitive economic, more flexible for large scale capacity, is catalyst handling, open license policy, iodide full service as the EPC contractor.
This is the process flow diagram of acetica process. There are two feet in this process. The carbon monoxide that received by the pipeline at the battery limit to the reaction level is compressed by carbon monoxide compressor. This is to remove the moisture contents in the carbon monoxide. Once the moisture is removed, the carbon monoxide is purged into the carbonylation reactor, while the fresh methanol fed into the absorber. The fresh methanol is split into two streams, each of which is fed to a separate countercurrent high pressure absorber and low pressure absorber. This is to enhance the absorbing efficiency. The part of the methanol fed contacts the reactor of gas in HP absorber, which contains the unconverted carbon monoxide, methyl iodide, methyl acetic, and so on. The other part of the methanol fed streams contacts the light gases in LP absorber, which were released at low pressure from distillation unit. The main purpose of this absorption system is to maximize recovery of valuable metal acetate and metal iodide, which otherwise will exceed the system with the vented gas, resulting in unnecessarily high chemical consumption and yield loss. The methanol feed streams exiting the absorbers are recombined and mixed with the recycled liquid from the recycle vessel and make up metal iodide from the MI generator unit. The combined and recycled streams is then charged to the bottom of the carbonylation reactor riser section. Now let me show you the principal reaction of acetica process. The methanol carbonylation reaction between methanol and carbon monoxide is conducted at moderate temperatures 170 to 190 degrees Celsius and pressures at 3.0 to 4.5 megapascal. This is the principal reaction of acetica process. There are two principal reactions here. The gaseous byproduct formation reactions such as water gas shift and methane formation also occur in carbonylation reactor, but losses of carbon monoxide and methanol by these reactions amount to less than 1% of the total feed. These are the reactions above. Do you know there is very small amounts of liquid byproducts are produced at the initial stage of plant operation, and their concentrations come to equilibrium, except for some heavy byproducts such as propionic acid. These heavy byproducts are eliminated with small purchase from the purification unit. The compressed carbon monoxide is fed through a sparger for even distribution. These feeds and catalysts, together with the circulation, flow from the downcomer and up the riser, where almost all the carbon monoxide and methanol are converted into acetic acid by carbonylation reaction. The difference in density between the gaseous carbon monoxide rich riser and carbon monoxide depleted downcomer drives the circulation. The agitation provided by the high velocities of the liquid and gaseous reactants rapidly dissolves the carbon monoxide into a liquid phase that reacts with methanol so that the system is not mass transfer controlled. The unreacted carbon monoxide and other gaseous byproducts are vented from the top of the separator to the HP absorber. A portion of the reactor liquid effluent is disengaged by gravity from the solids in the recycled slurry at the separator and sent to the downstream distillation unit. The remaining catalyst liquid mixture is routed through the reactor downcomer, cooled by the reactor cooler to remove the large heat of reaction, and returned to the bottom of the reactor riser to maintain the circulation. The reactor cooler generates the lower pressure steam by recovering the reaction heat, which is used as a heat source of the distillation unit. Catalyst retention in the reactor is almost 100%. Now the discharged liquid from the carbonylation reactor containing crude acetic acid product, methyl acetate, water, carbon monoxide and so on is flashed and vaporized in the flasher to separate vapor and liquid streams. A major portion of the acetic acid, unreacted methanol, methyl acetate, methyl iodide, water and some heavy impurities such as propionic acid are flashed into the vapor phase and fed to the dehydration column. At the same time, some heavy impurities are recycled from the bottom liquid streams containing acetic acid to the carbonylation reactor. The vapor streams from the flasher is sent to the dehydration column to remove the dissolved gases and liquid organic components and water. Now, the dehydrated acetic acid is fed to the finishing column, where the heavy byproducts are removed with small amounts of acetic acid in the bottom draw off and sent to the incinerator. The purified product acetic acid drawn from the middle of the upper distillation section is cooled and sent to the product treating unit. The overhead acetic acid containing small amounts of water and light organic compounds is written as a recycled streams. Small amounts of uncondensed light gaseous component containing traces of thermally cracked byproducts are removed as when gas to the waste treating unit. This is the iodide removal unit. Product acetic acid still contains traces of iodide compounds, which might harm the catalyst in a Wilm acetic plant. In this section, any remaining traces of iodide compounds are absorbed by a proprietary absorbent to reduce the level of iodide contains to less than 3 ppb. Now you can see a part of stream from the dehydration column receiver is fed to the excess water column to remove excess water and some of the accumulated impurities, and to maintain a constant concentration of water and impurities in the reactor. The overhead vapor is cooled and any uncondensed vapor is fed to the LP absorber for recovery. The water from the bottom of the column is also returned to the carbonylation reactor. Now the overhead stream is condensed and passed to the dehydration column receiver. In the receiver, uncondensed volatile materials consisting mainly of carbon monoxide with minor amounts of vaporized methyl iodide are sent to the LP absorber for recovery and to prevent yield loss. A part of the condensed liquid is sent to the excess water column The remaining of this stream is returned to the carbonylation reactor.
Distillation unit.
The purpose of distillation unit are production of purified acetic acid from crude acetic by purification, maintenance of the stable condition in terms of water content and impurities, recovery of value hydrocarbons including metal iodide.
Iodide removal unit. Product acetic acid still contains traces of iodide compounds which might harm the catalyst in a vinyl acetic plant. In this section, any remaining traces of iodide compounds are absorbed by a proprietary absorbent to reduce the level of the iodide contents to less than 3 ppb.